Welcome back. In this video, we're going to go over section 8.3, which is starting to look at addition and subtraction with rational expressions. When you're working with adding and subtracting rational expressions, you need to have a common denominator. And so this first section, 8.3, deals with a situation where you already have a common denominator. In the next section, 8.4, we'll actually look at ones where you don't and you have to make the common denominator. So let's start with 8.3. So the fact about addition, if P, Q, and R are polynomials and R is not zero, then to add P over R and Q over R, there again, notice the R's are the same, then you keep the same R on the bottom and you add the tops P plus Q. And that's it. That's how that goes. So let's try one with just numbers in it. We have 7/16 plus 5/16. That is going to be 7 plus 5 over 16. So I've kept the 16 in the bottom and added the tops. 7 plus 5 is 12. 12/16. Don't forget when you're doing an addition and subtraction of fractions to always simplify whenever you can. Here, 12/16 is going to simplify into 3/4. Okay, and that's how that goes. Add the numerators, keep the same denominator. Okay, let's try one with some variables in it. We have 5x over 2x plus 3 plus 2 over 2x plus 3. This will be 5x plus 2 over 2x plus 3. And that's it on this one. This one, there's no simplification that's possible. All right, here's one for you to try. Take a minute, pause the video, do this one yourself. Don't forget to see if there's a possible simplification. That's a big hint. And see how you did. All right, so here we're going to keep that same denominator of x plus 7, and we're going to add the numerators. So that's 9x plus 14 plus x squared. So good idea to always check and see if some simplification is possible. Right, sorry about that. Zoom crashed once again. All right, so we have x squared plus 9x plus 14 over x plus 7. I'm going to factor that x squared, 9x, and 14. And that will factor as x plus 7 times x plus 2. And sure enough, those x plus 7s will divide out, leaving us with x plus 2 after all that. So always remember to take a look for any simplification that can occur. Subtraction next. If you've got two polynomials, three polynomials, P, Q, and R is not zero, then P over R minus Q over R is P minus Q over R. So again, we'll keep the same denominator and subtract the numerators. So let's try that. Here we have x squared over x plus 3 minus 9 over x plus 3. So we'll subtract the numerators, giving us x squared minus 9. That's over x plus 3. That x squared minus 9, you're going to recognize will factor as x plus 3x minus 3. And so once you get that factored, you'll see that the two x plus 3's divide out, leaving just an x minus 3. Okay, here's one for you to try. The one with the n's in it. N squared over n minus 4 minus n plus 12 over n minus 4. Take a minute, pause the video, try this one yourself, and then restart the video and see how you did. All right, so in the bottom we'll have n minus 4. We're going to have n squared minus, and then the entire numerator of the second fraction needs to be subtracted. So you'll need to put that n plus 12 in parentheses. Otherwise, just the n is subtracted, but the 12 is added, when really we need both subtracted. So that shall be n squared minus n minus 12 over n minus 4. Okay, so then factoring that numerator, we'll get n minus, should be, I was thinking 6 and 2, but no, it looks more like 3 and 4. So n minus 4, n plus 3. That n minus 4 in the bottom should have been a tip off as well, right? So the two n minus 4's divide out, leaving us with n plus 3. It looks like a lot of these are rigged so that you get a nice simplification. That doesn't always happen, but sometimes you do get. All right, so this one, it looks like we're going to get a bunch of factoring to do first. Actually, no. The denominators are the same, so we're just going to subtract the numerators. I'm not going to worry about factoring until later, maybe. So we'll have 4x squared minus 11x plus 8. I think I was thinking about the multiplication we just did. Minus all three terms, 3x squared plus x minus 3. That will be all over x squared minus 3x plus 2. All right, so now I'm going to distribute to remove that parentheses, and then we'll work on combining like terms. Okay, so I've distributed the negative. Nothing happens in the bottom. So now let me, once again, keep the same bottom. And then 4x squared, I'm combining like terms in the top, okay. 4x squared minus 3x squared will be 1x squared. Negative 11x minus x will be negative 12x. And then 8 plus 3 is 11. Okay, so that's a little funny. Maybe I can factor that. X minus 11, x minus 1. Okay, double check by multiplying if you like. Make sure that works out. Down below, we should have x minus 1, x minus 2. Okay, and then you can see that the two x minus 1s are going to divide out, right? That will leave us x minus 11 in the top and x minus 2 in the bottom. Be careful you don't get cancel happy and divide out these x's and make the answer 11 halves, okay? You can only divide the numerator and denominator by common factors, and x isn't a factor here, okay? All right, so we're good, almost good. Okay, when the denominators are opposites, we're going to multiply one of the fractions by negative 1 over negative 1. Negative 1 over negative 1 is equal to 1, of course, and multiplying by 1 never hurts. So here it appears that the denominators are different, and yeah, they are different actually, but it's easy to make them the same by multiplying the numerator and denominator by negative 1. All right, so we'll keep the first fraction the same. You could multiply either fraction by that minus 1 over minus 1. It doesn't make a difference. I'm choosing to do the second one just because. All right, so down below we'll have negative 1 minus 3u. And so that makes it so that the second denominator is the same as the first. So that will be 3u minus 1. And up top we'll have a negative 1. So we'll have 4u minus 2 in the top and 3u minus 1 in the bottom. So the whole point for this example is if you have two denominators where they're just opposites of each other, then you can multiply the denominator and numerator of one of the fractions by negative 1 in order to make them the same. It looks like we're going to have that happen right here, and this is our last example too, so that's pretty great. So we've got y squared minus 5y over y squared minus 4. We're going to keep that the same. Like I said, if you want to multiply this one by minus 1, you can. Most times people don't. So we'll multiply the numerator of the second fraction and the denominator of the second fraction by negative 1. That doesn't change the value. It just changes the looks. So our first fraction is going to stay the same once again. And then in the denominator, that will give us y squared minus 4, which is what we want. And then the minus minus that we've got is going to turn into an addition, actually, isn't it? Okay, so we're going to add that 6y minus 6. All right, so down below we have y squared minus 4. And then combining terms, we'll have y squared plus 1y minus 6. All right, and then I should check and see if there's some simplification that can happen. So we're going to factor that numerator, and that looks like y plus 3, y minus 2. Down below, we'll have y plus 2, y minus 2. Okay, so here those two y minus 2's will divide out, and that will leave us with y plus 3 or y plus 2. So that's pretty great. that takes us to the end of this section on adding and subtracting rational expressions where the denominators are the same or are kind of mildly different. In the next section, we'll see what do you do if the denominators are like completely different. In the meantime, let me know if you have any questions and have a great day.